We now find the maximum and the minimum value of the function f of xy equals x squared plus y squared using the constraint equation x squared minus 2x plus y squared minus 4y equals 0. So this is our objective function, that is f of xy, and we have this constraint equation. So I'm going to rewrite this constraint equation as g of xy equals 0. So this implies g of xy is x squared minus 2x plus y squared minus 4y equals 0. So this basically represents the g of xy. We now iterate the condition that to find the maximum or minimum value of the function, it is understood that the gradient of f is parallel to the gradient of g. That is, we write down this as a gradient of f is some lambda times of gradient of g. So this equals, we can utilize the partial derivatives. Gradient of f is f sub x, which is the partial derivative of f with respect to x, and then comma f sub y, which is a partial derivative of f with respect to y. So this equals the gradient of g with respect to x multiplied with lambda is lambda times of g sub x plus lambda times of g sub y. So we will first find the corresponding partial derivatives. That is, we have to first find the f sub x, the partial derivative of f with respect to x. This gives f is x squared plus y squared. So f sub x will be 2x when we do the partial derivative of f with respect to x. And similarly, f sub y, that is the partial derivative of f with respect to y, is 2y. And then we will also find the partial derivative of g with respect to x. So we put this as a gx and also multiply this with lambda. So I put the lambda in front and find the partial derivative of g with respect to x. So we have g of xy equals this equation. When you do the partial derivative, we will get 2x minus of 2, rest of them are y terms, so it's just this quantity. And similarly, I'm going to find lambda times of g sub y, which is the partial derivative of g with respect to y. So I put this as lambda times of, we find the partial derivative of g with respect to y. So this x squared minus 2x will become 0, and then we will have 2y minus the partial derivative of 4y is 4. So we get this expression. So basically we get these two equation. We have this equation as well as this equation. Actually, these are the expressions of lambda gx and lambda gy. We have not yet formed the equation. So let's set up the equation. That is, using this, we can say that fx is lambda times of gx and fy is lambda times of gy. So therefore, when we put fx equals lambda gx, basically we will say that these two quantities are equal. That is, this gives us the equation 2x equals lambda times of 2x minus 2. We will get this simplified. So we have 2x equals, I can factor the 2 from this equation. So this becomes 2 times of lambda x minus 1. Now I divide both sides by 2, so I can actually remove this 2 over here as well as over here. And so finally this becomes x equals lambda times of x minus 1. In fact, we can solve for x from this equation. So let's do that. X equals, we have lambda times of x minus of lambda. I subtract lambda x from both sides, so I get x minus of lambda x. This equals negative lambda. Now I factor x from both sides. So I get x times of 1 minus lambda. This equals negative lambda. So we find x equals negative lambda divided by 1 minus lambda. So this is the expression for x. In the same way, we will now find the expression for y. So using these two equations, because we already said that Fy equals lambda times of Gy. So which means we will write the equation as 2y. This equals lambda times of 2y minus 4. Lambda times of 2y minus 4. We can factor the 2 from the right side expression. So this becomes 2 lambda times of y minus 2. We can divide both sides by 2. So therefore this becomes cancelled. So we get y equals lambda times of y minus 2. I distribute the lambda. So it becomes lambda times of y minus of 2 lambda. I subtract lambda y from both sides. So I get y minus of lambda y equals negative 2 lambda. Now I factor y. So I get y times of 1 minus lambda equals negative 2 lambda, which means we can now solve for y. So therefore y equals negative 2 lambda divided by 1 minus of lambda. So this is the expression for y, and we already found the expression for x, which is negative lambda divided by 1 minus lambda. So now that we have written the expression for x and y in terms of lambda, we substitute the values of x and y into the constraint equation. This is one of the equation we will utilize to find the value of lambda. So I'm going to replace x by negative lambda divided by 1 minus lambda into this equation, and when I do that, I get negative lambda divided by 1 minus lambda quantity square minus of 2 times of x, that is negative 2 times of x is negative lambda divided by 1 minus lambda plus y square, which is negative 2 lambda divided by 1 minus lambda, this quantity squared, minus 4 times of y, which is negative 2 lambda divided by 1 minus lambda, and this equals 0. So let's simplify this. So the first term, when you square it up, we will get lambda squared divided by 1 minus lambda quantity squared, minus this will become negative 2 times of negative lambda will become positive 2 lambda in the numerator divided by 1 minus lambda, and this will become a positive quantity for when you square it up, negative 2 lambda, we get 4 lambda squared divided by the denominator will become 1 minus lambda quantity squared. And here once again we have 2 minus, the product of 2 negative is positive. So I put plus 4 times of 2 is 8, and then we have lambda. So it is 8 lambda divided by 1 minus lambda. This equals 0. So we see that the common denominator is going to be 1 minus lambda quantity squared. So which means we have to multiply this term as well as this term, multiply and divide this term by this quantity. So when we do that, we will get lambda squared divided by 1 minus of lambda quantity squared plus 2 lambda. We just have to multiply only by the term 1 minus lambda and not by 1 minus lambda quantity squared. So I multiply and divide by 1 minus lambda. So therefore this will become 2 lambda times of 1 minus lambda in the numerator, and denominator, when I multiply 1 minus lambda with 1 minus lambda one more time, I get 1 minus lambda quantity squared. So then plus this has the common denominator 4 lambda squared. The common denominator is 1 minus lambda quantity squared. So we don't have to multiply this. So similarly, the last term, we multiply this 8 lambda with 1 minus lambda, both the numerator as well as the denominator. So the denominator becomes 1 minus lambda quantity squared, and this equals 0. So we have set up the common denominator as 1 minus lambda squared. So we can simplify the numerator, or in fact we can add the fractions. So the numerator expression will become lambda squared. We will distribute this 2 lambda times of 1 is 2 lambda, and 2 lambda minus lambda is negative 2 lambda squared, plus the next term is 4 lambda squared, plus we will also distribute the 8 lambda. So therefore this will become 8 lambda minus of 8 lambda squared all over 1 minus of lambda quantity squared, this equals 0. We now multiply both sides by this denominator, so that we will have only the numerator expression on the left side. On the right side, we will have only 0. And then we will combine the like terms. We have lambda squared minus 2 lambda squared. This is negative lambda squared. And then we have 4 lambda squared. So it becomes 3 lambda squared, and we have negative 8 lambda squared. So 3 lambda squared minus 8 lambda square is negative 5 lambda square. And now combine the 2 lambda, that is the lambda terms. We have 2 lambda plus 8 lambda, which is 10 lambda, and this equals 0. So we can determine the value of lambda using this equation. So we can, in fact, we can divide both sides by 5. So this becomes negative of lambda squared plus 2 lambda equals 0. We then factor lambda. So this becomes negative lambda plus 2 equals 0. And when we solve this, we get the value of lambda is 0. Or when we solve this equation, negative lambda plus 2 equals 0. So therefore, this gives lambda equals 2. So we now get two values of lambda, that is lambda equal to 0 or lambda equals 2. Since we have determined the value of lambda equals 0 or 2, we will utilize this and find the corresponding points. So I'm going to consider lambda equals 0 and substitute into this x as well as the y equation. So when I plug in lambda equal to 0 into the expression for x, I get x equals negative 0 divided by 1 minus 0. So 0 by 1 is 0. So we get x equal to 0, and similarly y is equal negative 2 times of 0 divided by 1 minus 0. Negative 2 times 0 is 0 over 1 is 0. So therefore we say that when lambda equals 0, the point is x comma y, which is 0 comma 0. And now we will find the another point using lambda equals 2. So similarly, we plug in the lambda equal to 2 into the equation, that is x equal to negative lambda, that is a negative of 2 divided by 1 minus of lambda, which is 1 minus 2. So in the numerator, we have negative 2 divided by 1 minus 2 is negative 1. So this gives the value of x is 2, and we plug in into the equation y. So therefore, this becomes negative 2 times of lambda, which is a negative 2 times of lambda is 2 here, and this becomes a 1 minus of 2. So we get negative 2 times of 2 is negative 4 divided by 1 minus 2 is negative 1, and this gives a positive 4. So therefore we say that the point is 2 comma 4. Now using the points, we will determine the maximum and the minimum values. So I'm going to use this point 0 comma 0 and substitute into the objective function. So therefore this becomes f of 0 comma 0 equals 0 squared plus 0 squared. This is 0. And let me substitute 2 comma 4 into the objective function. So therefore this becomes f of 2 comma 4. So it will be 2 squared plus 4 squared, and this gives 2 squared is 4 and 4 squared is 16. So this gives 20. And clearly this compared with 0 and 20, 0 is maximum, I'm sorry, 0 is minimum, and 20 is maximum. So we consider this value as maximum, that is the maximum value of this function is 20, and the minimum value of the function is 0. Therefore, we have determined the maximum and minimum value of the function f of xy equals x squared plus y squared.